Hello PLP Geometry, welcome to the second lesson in Unit 6. We are covering arc measure and arc length in a circle. So this is again Unit 6, where we are focused on circles. And this is the second lesson, which will focus on arc measure and arc length. Related but two different ideas. Okay, so before we start talking about arc measure and length, we need to talk about some angles, or an angle in a circle. And this angle is called a central angle. So a central angle. So a central angle is an angle in a circle. I'm using the angle symbol. Angle in circle with vertex at the center and sides as radii. And a central angle opens to its intercepted arc. So a central angle is an angle in a circle with vertex at the center and sides as radii, and it opens to its intercepted arc. So if I draw a picture of this over here, so here's my circle. My center is going to be point P. I'm going to draw two radii. So I'm going to draw P to A and P to B. My goal is to make it a little bit obtuse, right? This angle, so radii, this central angle, I'm going to say is 95 degrees. Okay? So there's my picture. So, an important idea, a big important idea. So the measure of the central angle is equal to the measure of the intercepted arc. This is a big one. The measure of central angle equals the measure of intercepted arc. So they're both measured in degrees. So in this picture, I'm telling you that the measure of angle APB is 95 degrees. Well, that means that the measure of arc AB, now watch what I do here, arc AB, because this angle opens up to this, let me do it in green. This angle opens to this intercepted arc AB. That means that the measure of arc AB is also 95 degrees. This is our first time talking about arc measure. So this is also 95 degrees. And again, this is why the measure of a central angle is equal to the measure of its intercepted arc. Okay, so let's talk about some different arcs in a circle. Depending on their size, they have different names. Okay, so let me draw this picture again. Okay, center is P. Let me stick with PA and PB. Let's let this be 95 degrees again. But now let's extend AP all the way across, creating a diameter. Let's call that point C. And then I'm going to put a point D somewhere out here randomly. It doesn't matter where D goes. Okay. All right. So let us first talk about what's called a semicircle. So a semicircle, right, is an arc representing half the circle. Half the circle. So when you think of a semicircle, I want you to think of a diameter, because a diameter is a segment that splits the circle into two half half circles. So the two arcs that the diameter splits it into are both going to be semicircles. So the diameter in this picture is AC, which creates two arcs. Now there's an arc starting at A going clockwise and an arc starting at A going counterclockwise. Because of this idea, we need to name a semicircle with 3 letters. So the one to the right is going to be ABC. So the measure of arc ABC. Now the semicircle to the left is going to be ADC. They'll be equal because they're both semicircles, ADC. And that measure that they're going to equal is going to be 180 degrees because they're half the circle. A circle is 360, half the circle is 180. So again, you're going to name these with 3 points. Okay, next is a minor arc. A minor arc. So a minor arc is going to be a smaller arc than a semicircle. So a minor arc is an arc smaller than a semicircle. You can't spell right now. Semicircle. Arc smaller than a semicircle. So in this picture, right, I know that AB is a minor arc because its central angle is 95, so arc AB also measures 95. So I know that the measure of arc AB is equal to 95 degrees, and it's a minor arc. I can also find this arc right here, BC. Its central angle is BPC. These two central angles together make a line, a diameter. So they're equal to 180. So we're going to take 180 minus the one I know. So to find the measure of arc BC, I'm going to take 180 minus 95. And that gives me an arc measure of 85 degrees. And again, we're going to use 2 points when we name a minor arc because, it's smaller, right? Okay, and then the last type of arc we're going to talk about is a major arc. A major arc is an arc larger than a semicircle. Okay, so in this picture there are a couple, right? So let's talk about arc ADB. So I'm going to find the measure of arc ADB. Well, if you look at arc ADB, A to D to B. Notice I passed C. You don't have to name every letter that goes, like every point it goes through. So I'm going past C. So ADC is a semicircle. I'm going past it to point B. Now there are 2 ways to think about this, right? Number 1 is, if you look at this blue arc, it is everything in the circle but the 95. So to find the measure of that major arc, I could take the circle 360 and just subtract what I don't care about, which is 95. So this is the subtractive way. The other way I could do this is I could take the semicircle, which is ADC, which is 180, and add this minor arc here, which is 85. Either way you go about doing this, you're going to get the same answer of 265 degrees. If we talk about another major arc, how about BDC? So again, B to D to C, right? So now if I want to find the measure of arc BDC, so now I could do 360 minus, and now I don't care about 85. You can see my purple. Or I could do, so BDC, I could take the 95 degrees and add the semicircle of 180. Again, no matter how you do it, you're going to get 275. Now, arc BDC is the same as arc CDB. So this is also arc CDB. CDB. dB, right? It ends and it stops and it goes the same direction. So you just start the one letter, go through the other one, and end at the third letter. And again, you name these with 3 points. Okay, so I'm going to stop this video here. We will have a second video talking about arc length. All right, so stay tuned.